All right, let's go ahead and build the Bouncy Ball app, shall we? So we're talking about all the way down here at the end during the final of CIS 150 AB, there's this Bouncy Ball app. It's the second part of the final. So it's worth 75 points. Let's make sure we do it right. So first thing we're going to do is we're going to open up the books. And on page 220, you'll see under organizing data, there is a build a Bouncy Ball app, 220. So follow the instructions here and build a Bouncy Ball app, right? That should be simple. Well, let's do this together, shall we? So when it's all said and done, we want something to look like this. Blink. You can move the sprites around, little ball drops at the top. Move the sprites around, and using SK Physics probably, we are going to bounce around the ball when it drops. Doink, doink. Interesting. It's not touching these little green and yellow ones, but it is touching the brown ones. So they're probably using some kind of collision detection, and also different, like, you can kind of group things in different ways to make them collide and not collide. So let's see how to get started here. Open the project called Bouncy Ball Xcode project from your curriculum folder and click the run button. Oh, they're really kind of making it easy for you. You don't have to start from scratch, do you? Huh. That's cool. Alright, so I'm going to close out all my other Xcode windows, and then from this screen I'm going to open the project, or you can just double click on the project. Let's look at the student files, and let's look for something that says Bouncy Ball. Okay, so it's in this folder here, and here's the Bouncy Ball Xcode project file. Let's open that up. Oh man, they did all kinds of work for us. This is great. Usually you'd have to build all this yourself. So let's take a look at what files we got here. Let's just click through it a little bit. So this is just the Xcode project file with all the settings and stuff. Version number. If you were making your own app, you would adjust the version number, the build number. So the build number, I guess I can go through this since we're here. Build number is while you're building this version of the app. Sometimes you got to make revisions like build 1, build 2, build 3, build 4. Xcode does not automatically increment the build number, so you might want to make changes to it. So this is just for your programming team. This is the official version that's in the App Store, and this version actually has to match up what version's in the App Store that you're submitting the app to. So when you upload your app, this version number has to match the version number in the store for it to be accessible by your app build, your submission. So anyhow, the bundle ID is really important too. That's your unique identifier for your app when you submit it to the App Store. Okay, let's look at this Swift file here. Game code. So it looks like we might be doing some stuff in the setup function here. Doesn't really have much there. Looks like there's a Swift file here for the shape scene. And looks like we got a lot of work in here and stuff. They've got some protocols and extensions and some pretty fancy stuff here. So anyhow, this is some physics stuff. Let's wow, it's like there's like 1,000 lines here. Look at that. And so I'm just clicking around just to see what we got already. I'm just going to try to build this thing and see what happens. Let's just build and run it. I want to build and run it on the iPhone 11 Pro Max. You can build it on whichever thing you want. We can see this is using storyboards, so it is not a Swift UI application. It's just a standard Swift application, which is great. I'm going to click on the simulator just to see it. Yep, it's loading, so let's give it some time. And the first time you launch a simulator, any simulator for the first time, it needs to take a while to load all the files in. But the subsequent launches should be much faster. Okay, there's the launch screen. Not very exciting, just a white screen. Maybe put a logo here eventually. That might be kind of nice. Huh, okay, maybe that's it. Let me look on the book here. You should see an empty white screen with gray bars at the top and bottom. Okay, yeah, it's working. It looks great. Are we finished? Probably not. You'll build the game from simple elements, flat shapes that can interact with touches, and physics simulation. I accidentally highlighted that. The code that implements the game engine is written in the shape.swift file and shapescene.swift file. In turn, the game's engine is written on top of standard iOS SpriteKit API. SpriteKit's it's cool. It's like kind of like the Angry Birds kind of stuff is written in SpriteKit, and it's where you take little objects and they can interact with each other. And it's for like little video games and stuff. Like not 3D video games usually, but more like 2D flat video games. I could be wrong about that. I've never built a 3D game, so maybe it uses SpriteKit too. To start, use the Project Navigator to open gamecode.swift. This is the only file you'll need to modify as you create the game. Okay, that's good to know. I didn't mean to. I keep adding all these notes. Oh, geez. Oh, I don't know how to close out the notes either. Okay, whatever. Remove highlight. Remove. Okay. You'll notice game.swift file is already one function called setup. This function is called once when the app launches. Without it, your app won't compile. You'll now use it to set up your game. Build and run the app to see how it looks before you add any content. You should see a white screen. Yep. And it's time to add your first shape. At the very top of the file, just below import foundation, add this line. I'm going to guess it's going to be import SpriteKit. I am totally wrong. Let's circle equal oval shape. Okay. Well, let's do this then. I'm going to move this to my other screen so I can look at it and reference it. So what they're saying is over here, first of all, let's stop the simulator so it's not running in the background and using up our processor. And they said we just got to go into the game code up here at the top. And it wanted something at the top here called circle. I'm going to get rid of this comment. I don't want it there. I want my code to be clean. So circle equal oval shape. And then it's going to have a width and a height. So we'll enter in a width of, it says 150 and the height of 150. Okay, so now in the setup, so we've made this thing called circle. And it's just out there. It's accessible but to this function because it's not inside of a structure or class or anything like that. It's kind of like exposed, as they say. And so let's call circle now and set the position of the circle. You always have to kind of set the position of things before you drop them on your scene in SpriteKit. Once you set the position, you can move it afterwards as well. And there's something called scene already. They're making this easy for you, I'm telling you, because where is scene defined? Like, look. So I'm going to hold down the Alt key and click on scene. It's declared in the utilities, so it's declared in this utilities Swift file. So I'm going to click on that, and yeah, here's the scene, and that just returns the view controller shape scene. Where is SpriteKit? Defined. I see. It's in this shape scene and in the shape file and in the view controller. So they've imported it in the view controllers already for you, so you don't have to import that, which is nice of them. Alright, so all we got to worry about is this game code, they said. Alright, so we did that. Can we just build it? Let's see what happens. Oh, check that out. There's a circle there. Is it, if it's SpriteKit, we might be able to, yep. Look at that, you can click and drag it around and everything. It doesn't have any physics on it, so we'll have to add the physics to the scene. So like add gravity to the scene, I believe. So we'll have to probably do that later. Let's see how they proceed. Next page, adding physics. It's almost as if I've done this before. Okay, circle has physics equals true. Oh, that's cool. They've already kind of set up some basic gravity and whatnot. So we'll type circle dot has physics and assign it to true. So this is important because you don't always want like things dropping out of the sky. So like you might want some fixed position things like the, remember when we launched the app before, there were those little bars that you could drag around. So those aren't falling to the ground, but the ball is. So let's launch the ball again, see if it can fall now. Oh, there it goes, off the screen. So sometimes you put a border around the edge of the screen so things will bounce around on the screen. That's always fun to do. I don't think we're doing that in this app though. And I'm moving on to the next page. The next page says, run the app now to observe gravity. It's time to add a second object, the barrier the ball will bump into. This new shape will be a rectangle rather than a circle. So you need a different type, polygon shape. Add the following declaration. Da 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 da. So I'm going to move this up here and I'll do some typing. By the way, like, I'm not like down with just this giant setups, you know, like putting everything in the setup here. You would normally like have a function called add circle and a function called like add barrier, something like that. But whatever, I'll just follow the instructions for now. Oh, I see. They actually want us to put it up here. Okay, that makes a little more sense. So we're going to adjust the barrier width here, so we can just define it up top. That way, every time you create a new barrier, the barrier width can be the same. And then the barrier height. These are doubles that we're making because there is a decimal point. So if there's a decimal point, then Swift is going to infer that they are doubles. I'm a little stuffy today, I apologize. I guess I'm stuffy every day. All right, it also wants to make us to make barrier points. Joints. And assign it to an array. And it's an array of points, basically. Okay, so the first point, you would type out this point and then open parentheses, and looks like it's got an XY coordinate. The first point will just start out at 0, 0, and I'm going to put a comma between each of these different points here. So I'm just going to see how many they want. 1, 2, 3, 4. So 1, 2, comma, 3, comma, 4. Okay, so now there's 4 points. They're all at the same point now, but I'm going to change that up a little. So the first one 0, 0. Second one is 0 barrier height. Next one is barrier width. And then barrier height. And so what this is doing essentially is like drawing a rectangle around, drawing a line around the rectangle that we're going to build. Kind of cool. I like that. And then the last one is width. Okay. So now that we've got all those points, we've got to create like a polygon shape. So they've got the points, but now we got to make the shape. So the actual barrier shape, I'm going to call it barrier shape. Or no, let's call it barrier. Assign it to the polygon shape with the points. So the polygon shape actually just already takes an array of points, which is perfect because we already have all the barrier points made up here. Actually, it should be barrier points, plural. All right, cool. So now here's our barrier. We got to actually add to the scene though, right? So, yep, scene has barrier. Scene dot add barrier. It probably shouldn't matter, but I'm going to cut this out. I'm going to put the barrier in before I put the circle in, just in case the circle drops and misses the barrier. So the barrier should go on the scene first. It's not going to happen because things happen so fast, but you never know. So it wants us to build and run it now. Now, I have a sneaking suspicion that the circle is just going to fall right through the barrier because we haven't said the barrier can have collision yet. Well, first of all, the barrier is like not even close to the ball. So let's scoot the barrier position over. So I'm going to copy and paste this, and instead of circle position, I'm going to say barrier position, and its X is going to be the same, so it's right underneath, roughly speaking. It might have to be a little bit less. and then the Y will put it up higher, or lower, I'm sorry. So we'll put it at 200. I think that should put the barrier underneath the ball. Yeah, see, it fell right through it. Zoop. And the reason is because this is not really defined as something that can collide yet. You have to be very specific about what can collide with what. Okay, so it wants us to add this thing called isImmobile and set it to true. It's kind of already... Oops. Wait a second, maybe I missed something. Did they add the... barrier has physics too. So they want the barrier to have physics and also be immobile. So let's go back over here then. So I have the barrier. So I have a feeling. So once you, I gotta go to a meeting. So I will come back. Okay, I'm back. So where were we? We were adding physics to the barrier, right? So let me reorganize this a little bit. It's kind of, I think the circle stuff should be together and the barrier stuff should be together. So we want to make the barrier before we want to make the circle, just in case the circle gets there first. So we want to add physics then to the barrier before we dump it on the screen. So has physics equals true. Now this would make it fall from the sky, so we also want to add this extra thing, which is immobile equals true. Looks like it defaults to false. It's not immobile. But if we wanted, we could probably, just to define it a little further, we could define the circle as saying isImmobile false, just so now they match. Alright, let's see what happens when we do this. Now the idea is the ball falls, hits the barrier. Doink! There it is. And should we see that again? It's not really dynamic, right? Because it just kind of drops down like I don't know, like a lead weight. But I think when you kind of want it to bounce a little bit. So bounce is called, I think in this it's called restitution. I wonder if we can just do that, if it's allowed. Circle.restitution. No, it's not. It's not the right type of object for that. But oh, I think it's like circle physics body. Oh gosh. All right, it's not set up to do that. But let's see what they have us do in the book. Okay, building that, run the app. Ball comes to rest on it. Oh, the ball's still responsive to touch, so we could have dragged the ball around and dropped it again. That's cool. Okay, it wants us to add a funnel, a new shape called funnel. I'm going to just grab this and copy it. It's going to be ugly, but it'll be easier. We want to create the funnel in the same spot that we created the barrier. Okay, we can do that. I mean, ultimately, you'd think you'd probably want to put these things somewhere else, but that's fine. So whenever you paste stuff in, it puts these little quotation marks around it, and then this excerpt. So we're going to get rid of that. Playgrounds doesn't like us to do that. And then we want to add the funnel to the screen. Sometimes these blank spaces cause problems too. Okay, so down here underneath scene, add circle, let's add funnel in here. So first of all, there's a thing called funnel that we just made. It's got a position. On the position, we're going to assign it to a point. And the point is going to be, X position is going to be 200, and the Y position is going to be, it's going to be relative to the scene, right? So scene, because we want it to be at the top of the screen. So scene height minus 25. Then we want to add the funnel to the scene, or add the scene to the funnel. Add the funnel to the scene. Now it's getting a little later in the day. I don't have as much coffee in me. Alright, so the scene's there. Now, the scene doesn't have physics, so it should just stay there. It's not going to drop from the sky. Let's see. Okay, there it is. Boink. Oh, look, there is some restitution to it. Doink. It's just got to drop. There's some bounce to it. It's just got to drop higher. Whoa, you can fling the ball pretty high up. And now I think I lost the ball. Alright, so we want to make it so when you click on this, it drops the ball. Now the ball looks pretty big to me, right? It doesn't match the size of the funnel. Oval shape. Well, let's drop it down to 50. This isn't really in the instructions yet, but it's kind of bugging me. How's that ball ever going to fit through the funnel? Okay, that's a little more believable, right? So let's make it even a little smaller, and then we'll move on. Alright, so it says here, we add it to the scene. We added it to the scene. When they tap the funnel, we want the ball to drop. Yes. First, we'll make the function to drop the ball. Okay. And it's just going to put the ball in the funnel position. Yeah, and then we can call on tapped. That's cool. Okay, let's do this. So where do we put that function? Well, they said all of our stuff is supposed to be in this game code page. So I guess we'll put the function here outside of, not inside of the setup. The function should be outside of the setup. Call it drop ball. And then basically we want to reference the circle, and the circle's position will equal the funnel's position. So we're kind of moving the circle back to that position. And that's it, because it'll just drop, right? Well, we need somewhere to set up the funnels on tap. And so we might as well set it up here, right before it's added to the scene. So before it's added to the scene, we'll say on touch, or on tapped, then drop the ball. Something like that. I'm looking into this problem here. So typically you'd put those parentheses in when you're calling a function, but it looks like it doesn't want the parentheses, so that is interesting. Okay, so this is how you set it up. Usually you'd put the parentheses in, but OnTap doesn't want to see the parentheses. Fine, I'm not going to argue. That's why I was getting the error before. And off we go. So let's give this a try. I think it'll work now. It'll drop the ball there. I don't think we have to add the... We should add the circle like off the screen for the first try maybe, because it's going to go boink there, and we want it to go like that. Look at that. It even looks right. You can click it a bunch and it'll drop again and again. It just basically, it's not dropping a new ball. It's clearly moving this ball. You know what I kind of like to do, honestly, is I'd kind of like to not move it. In this function, I kind of want to create a new one. You know, I mean, I know then we're going to have to, if you do this, then ultimately you have to track how many sprites are on the screen and then start removing sprites from the screen, or your app is going to start to slow down. You know, so usually you have to create a count of sprites and then remove the oldest ones from the view. But, I mean, like I kind of want to just add another one just for fun right now. So, what if we do this? Yeah, to do that, I mean, like to do that proper, we would want to create a whole new oval shape inside of here. So, create a new circle. So we're not referencing the circle out here. We'd be creating a brand new one. So I'll just call this new circle. And then we can do all this circle stuff down here. But instead of the position is going to be, so the new circle position is going to be the funnel position. This is not in the book. I'm sorry, guys. I'm going off script here. I really shouldn't, because I know your time is valuable, but I kind of just want to do this for fun. guess I should save the fun stuff for some other time. Okay, so now we've got one ball that drops. In fact, I'm going to get rid of that ball that drops for the moment, and we're just going to create a new one. And again, like, don't drop too many or your app will start to slow down because we're not tracking how many circles there are going to be. Typically, you'll also check to see if something goes off the screen, then you remove it from the scene. There we go. That's what I was looking for. Now look, we can move this funnel around. I don't know if that's important or not, but the cool thing is now if you drop another ball on, boink, they bounce off each other, which I think is really cool. Boink. Okay. So there you go. There is a way to show how many sprites are on the screen. It's like a log view for that. I'm not going to show you how to do it now, but so you can track how many sprites are on the screen. That way you can also check the what's it called? The frame rate of the view. So if there's too many sprites on the screen, the frame rate goes down and down. Your app starts to get slow. So that's what if you're really making this for real, you'd want to track how many sprites are on the screen and remove any sprites that are no longer relevant, like they go way off the screen, or you just have a maximum count of sprites and then you remove the oldest one maybe when a new one drops on the screen, something like that. Okay, this was just my fun thing. Let's keep moving. I'm going to leave the fun thing in. And if you do submit this assignment for me, I will be okay with it if you leave that fun thing in. It doesn't have to match exactly. Okay, I'm always clicking around and accidentally highlighted this. Tidying things up. Your shapes are a little boring, and the ball is way too big to fit in the funnel. I fixed that already. It's time to add a little artistry to your game. Okay, so let's add some color to the shapes. So this next section talks about refactoring and tidying things up. I've added a little blue color to my circle already, and I've already changed the size of the oval previously. So I put the fill color in down here. So new circle, fill color equals blue, 40-40, 40 width, 40 height. But then it goes into talking about refactoring your code. And there's a couple neat things here. Now, the first thing it wants us to do is to basically pull these out and put them into their own functions. And I'll show you how to do that. There's actually a couple ways to do it. I mean, you could just create a function, and that's kind of what I did with this drop ball down here. So, but let's say we want to create a function from the barrier. Well, there's this new thing that maybe it's not new, but I never knew about it. You go to Editor, so you select what you're interested in extracting, and then go to Editor, Refactor, and then you can do Extract to Method. I want to extract it to a method, and what it does is it pulls this code out and pretty much just drops it in a function. Let's call the function something. We're going to call it setup barrier. And there you go. So now we've extracted it. Now you'll notice there's an interesting descriptor for the function. This is called a file private function. And that's kind of important because when you define like properties just outside of a class or a structure, they're like exposed across your entire app, which is sometimes good and sometimes not so good. Like if you have a bunch of variables and properties and functions just exposed, it's going to slow down your app. It's going to be clunky. It's going to it's problematic. Let's put it at that. It's problematic because it's going to be messy code. Like when you go to create something new called setup, then it's like, is it the setup on this page or that page, or which page set up what? So you always want to kind of put things inside of like structures or classes or protocols or enums, or you want to kind of contain your code. But let's say you want to do it this way for the sake of argument. You add this file private function. So file private label to the function, which means that this function setup barrier that we just made is only available in this Swift file. So what I'm going to do actually just to speed things up is I'm actually going to plunk file private in front of everything here. So that way only this file can access these properties. And I'll just make my machine move better. Now I am not going to put file private in front of setup because actually the view controller or the scene controller or something like that actually references setup, so we'll leave that one exposed. But all these other ones are going to be file private now. So that's kind of cool. The other way, so we've extracted the setup barrier, and so now in our setup there's this. We don't need to create this circle anymore because we're only creating the circle when you touch the funnel, tap the funnel I should say. And so let's extract the funnel also. So refactor, extract a method, and we'll make a setup funnel method. Setup funnel. Okay, so there we go. Now our setup is a little bit cleaner, right? So this whole setup function down here, and when it runs, it's just like setup barrier, setup funnel, done. The other thing they want to show you how to do is how to rename things, and there's a couple different ways. What I usually do, or used to do more, I kind of still do it a lot, is you double click on what it is you want to rename. You Command C to copy, Command F to find. You can also just click on find here, and then Command V, and I'm pasting this into the find here. And there's a little drop down here, and you click the replace button, and then you can rename stuff. Now then you can just hit enter, enter, enter as you're reviewing them, or you can just click replace all over here and replace them all. The other way to rename things is you can right click over something that you made, and then you can go to refactor, rename. And it might take a moment, especially if you've got stuff all across your app, but eventually the screen will kind of adjust. Zoop. And now you can type in and it'll rename it everywhere. So I'm not going to rename it barrier. So I'm going to hit Command Z and it'll undo that. So that's it. That's refactoring. Refactoring is cleaning up your code, making it more readable, making it more reusable, making your code better. So we've done that. And now we're into part 5. I think I'm going to pause the video here and then create a second video for part 5, 6, 7. I'm not sure how many videos I'm going to make. It might be a 3-parter again, but I'll try to keep them under 30 minutes if possible.